Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. So today we will continue with the second chapter, which is the direct current DC circuits. So today we will cover subchapter 2.9 until subchapter 2.12. So this will cover the series resistance and voltage divider, and also parallel resistance and current divider. Okay, so basically this today we will focus on the voltage divider and the current divider. However, before we can do the voltage divider and current divider, it's very important for you to know the difference between the series circuit and also parallel circuit. So basically this one you already learned in the previous week, and I'm sure that you guys already able to differentiate what is series, what is parallel circuit. Okay, but maybe some of you still quite confused if you're given a circuit, because some of you did WhatsApp me during the weekend asking about the tutorial. Okay, so if I'm not mistaken, tutorial 2 question number 11. So some of you think that that circuit is a parallel circuit, but instead that one is a series circuit. So please make sure that you're able to differentiate between parallel and also series circuit. Okay. Okay, so now let's start with the series circuit. So basically, this is just a repetition. What is series, what is parallel? So basically, for a series circuit, you have a connection like this, where you have the circuit element connected in cascaded. Okay. So over here is two or more elements are in series if they are cascaded or connected sequentially and consequently carry the same current. So if you have a series circuit like this, okay, the current that flows here is the same. Okay, so basically the current I here is the same as the current that flows through R1, and also it is the same as the current that flows through R2. Okay, so that's why over here you have I1 is equals to I2 is equals to I. Okay, so remember, if you have a series circuit like this, you don't need to do KCL, Kirchhoff current law. You don't need to do KCL because the current over here is the same. Okay, so and another thing, if you have a series circuit like this, to find the equivalent resistance, okay, the equivalent resistance, or we name it as RQ, R equivalent. So to find the R equivalent, basically you just add the resistor. So over here you have R1 and R2. So the R equivalent for this circuit is basically R1 plus R2. Okay. But if you have, for example, you have 4 resistors, then connected in series, so the R equivalent is R1 plus R2 plus R3 and plus R4. Okay. So basically, after you find the R equivalent, basically you can simplify from this circuit to this circuit. Okay, so instead now you have two resistor like connected in series like this. Now you just use one resistor with the value of R equivalent. Okay, and this one is the parallel circuit. So for parallel connection, you have a circuit that is connected like this. Okay, over here is stated that they are connected to the same two nodes. To the same two nodes. So you must have two nodes. So this is the first node, node A. This is the second node, node B. So connected to the same two nodes. Okay. So for this one, for parallel circuit, basically the voltage that flows here, no, not the voltage that flows through R1. The voltage at R1 is the same as the voltage at R2, and is the same as voltage V. Okay, so if you have a parallel connection, the voltage is the same. Okay, V1 equals to V2 equals to V. For the series circuit, the current is the same. Okay. So if you have a parallel circuit like this, you can still calculate for the R equivalent. Okay. So for example, you have two resistors like this. To calculate for the R equivalent, you just use this formula where 1 over R equivalent is equals to 1 over R1 plus 1 over R2. Okay. Or basically, this is R equivalent is 1 over R1 plus 1 over R2. Okay. So using this formula, you can get the R equivalent. So you can simplify this circuit from this parallel circuit. You can simplify it to become this circuit. With the resistor here is now the R equivalent. Okay. So now let's look at example 2.9 at page 47. So you have this circuit, okay, and the question asks you to find the R equivalent. So the R equivalent is the total resistance, okay, looking from here. Okay, so if you have a circuit like this, to find the R equivalent, you must make sure that you start from here. Okay, so now let's do example 2.9. Okay, so this is the calculation for example 2.9. I hope that you can jot this down because it is not in your slide. Okay, so the question here, you have this circuit. The question asks you to find the R equivalent. Okay, so the first step is you must differentiate which one is series, which one is connected in parallel. So from this circuit, you can know that this 5 ohm and 1 ohm is in series. Okay, then you can simplify this, and I name this as R equivalent 1. Okay, so I name this as R equivalent 1. Okay, so R equivalent 1. Okay, so R equivalent 1 is basically, because it's a series circuit, then it is 5 plus 1 and you will get 6 ohm. Okay, so from this circuit, you can simplify it to be the circuit in number 2. Okay, so the circuit in front here is the same. You have 4 ohm, 2 ohm, 6 ohm, 3 ohm and also 8 ohm. But the circuit at the back here is now is the R equivalent 1. So where the R equivalent 1 is actually equals to 6. Okay, next you need to determine which resistor that you can simplify. So over here you can see that this 6 ohm and 3 ohm is connected in parallel. So this one, I name it as R equivalent 2. Okay, so using the formula for the R equivalent connected into parallel, so the R equivalent 2 is basically 1 divided by 1 over 6 plus 1 over 3. Okay, so if you calculate this, you will get it is equals to 2 ohm. Okay, so and then from this circuit, you can further simplify it to be this circuit. Okay, now you have 4 ohm, 8 ohm, 2 ohm, and this is the R equivalent 2, which equals to 2 ohms. Okay, and now from this circuit, you can simplify this because this is connected in series. So I name this as R equivalent 3, where R equivalent 3 is equals to 2 plus 2. So it is equals to 4 ohm. Okay, then I further simplified this to become this circuit. So now this is 4 ohm, 8 ohm, and this is the R equivalent 3 that we have calculated, which is 4, and we have 6 ohm over here. Okay, so you can see that 4 ohms and 6 ohm is a parallel circuit. So I name this as R equivalent 4. So to find R equivalent 4, use the formula 1 over 4 plus 1 over 6, and you will get 2.4 ohms. Okay. And lastly, simplify the circuit. You have 4 ohm, 8 ohm, and this is the R equivalent 4, which is the 2.4 ohm. And lastly, you can calculate the R equivalent. Is basically this is a series circuit. So series 4 ohm plus 8 ohm plus 2.4 ohms. So it will equals to 14.4 ohms. Okay, so the final answer for the R equivalent is 14.4 ohms. So any question? Can you understand example 2.9? How to calculate for the R equivalent if you have a circuit like this? Okay, so I hope everyone understand this example 2.9. Okay, and then let's continue. Okay, so next let's continue with practice problem 2.9 at page 4. At page 48. Okay, so you have this circuit. Find the R equivalent. Okay, find the R equivalent. Okay, so over here I don't have the calculation for practice problem 2.9. So I think we need to do it. Can you do this? Can you find the R equivalent for this circuit? Basically, you already have the answer over here. So over here, to find the R equivalent for this circuit, you need to start from the right hand side. So over here, you know that 4 ohms and 5 ohm, 3 ohm is series, correct? 4 ohms, 5 ohm and 3 ohm is in series. So basically the R equivalent is equals to R equivalent 1 here, 4, 5, 3 ohm equals to, can someone answer? 12. Okay. So since this is a series circuit, so 4 ohm, 5 ohm, 3 ohm is equals to 12. Okay. So that's why from this circuit, you can draw this circuit. Okay. Now, instead of having 4 ohm, 5 ohm and 3 ohm, now you only have a single resistor over here with the value of 12 ohms. Okay. So next, from this circuit, you can see that the 4 ohms and 12 ohms here is in parallel. So please calculate for the R equivalent to, where 1 over 4 plus 1 over 12. So this one, 4 parallel with 12, the R equivalent is equals to,
we got 3. The
3.
R equivalent 2.
Yeah, the R equivalent to is equals to 3. So that's why you simplify this circuit, so it become, you have 2, you have 6, you have 1, you have 3, and now the 4 ohms and 12 ohms, you can change it to be R equivalent 2, which is equals to 3. So you have this circuit. Okay. So now from this circuit, you can see that 3 ohms and 3 ohm is connected in series. So the R equivalent 3 is equals to 6. Okay. So from this circuit, you can convert it to this circuit. So you have the R equivalent 3 now is equals to 6. So you can see that 6 ohm and 6 ohm is in parallel. So you need to calculate the R equivalent 4. And you will get equals to 3. And the final circuit, you have something like this. You have 3 ohms, you have 3 ohm, 2 ohms, and also 1 ohm in series. Okay, so to find the R equivalent is basically you just add the 2 ohms, 3 ohm plus 1 ohm, and you will get equals to 6 ohm. So any question for practice problem 2.9? Simple, right? Okay. And next, let's proceed to example 2.10. Okay, so the answer is 6 ohm. So now let's proceed to example 2.10 in page 48. So you have given this circuit. Calculate the resistance RAB. So RAB is looking from this side. Okay, RAB is actually the same as R equivalent. It's just that it name it as RAB. Okay, so now let's do this one. So this is the calculation for practice problem 2.10. Okay, so please make sure that you jot this down while I explain it to you. Okay. No, not this one. This one. Example 2.10. Okay, this one. Okay, so basically from this problem 2.10. Sorry, Okay, I forgot to print the example 2.10. I forgot to scan the example 2.10, but it's okay that we need to do it manually. Okay, for this circuit, if you have this circuit, the first thing that you need to do, my advice is that you need to redraw the circuit. Okay, please redraw the circuit. Okay, because if you look at this circuit roughly like this, you might get confused at part. Okay, which one is connected at which nodes. Okay, so if you have a question like this, please redraw the circuit. Okay, so the first step is redraw the circuit. So first you have 10 ohm. Okay, and you have node C over here, and then you have 1 ohm resistor. Okay, and this is node D. Okay, and at the bottom you have a single node, which is the node B. Okay, so now from node D, we have 1 ohm and also 5 ohm. Okay, we have 1 ohm and also 5 ohm. connected from node D to node B. Okay, this is D, this is C, and this is B. Okay, and then we have another branch. Okay, from node D, you have one resistor 4 ohm connected to node B. Okay, and then another branch connected to node B, which is this is 12 ohm. Okay, and then from this node C, you have a resistor 6 ohm connected to node B, and then from another one, from node C, we have another resistor connected to node B. Okay, so this is the circuit that I redraw. Okay, so this is 10 ohm, this is 1 ohm, this is 1 ohm, this is 5, this is 4, this is 12, this is 6, and this is 3. Okay, so the first step, redraw. Then from this circuit, you want to find the RAB. So RAB is looking from this side. This is A, this is B. Okay, this is the same node B. Okay, so the first step here, from the right hand side, you can see that this resistor 1 and 5 is in series. So I name this as REQ1. So REQ1 is equals to 5 plus 1. So this is equals to 6 ohm. Okay. Then the second one, you can redraw this circuit again, the simplified one. Okay. So instead of having 1 and 5 ohm, now you only have a single resistor, which is equals to REQ1, which is 6 ohm. Okay. And then this is 4 ohm. This is 12 ohm. This is 6 ohm. And this is 3 ohm. Okay. Okay, so from this circuit, you can see that the 12 ohm, 4 ohms, and 6 ohms is connected in parallel. Okay, so I name this as REQ2. So REQ2 is equals to 1 over 12 plus 1 over 4 plus 1 over 6. So this one is equals to, can anyone calculate this? REQ2 is equals to
2.
2. Okay, so REQ2 is equals to 2 ohm. Okay, so next you can redraw the circuit. Now you have, this is 10 ohm, and then you have 1 ohm. This is not B, so this is 2 ohm. This is 1 ohm. Okay, and then we have 6 and 3. Okay, so this is actually a single line. This is 10. Okay, so now you know that this 1 ohm and 2 ohm is series. So REQ3 is equals to 1 plus 2. So is equals to 3 ohm. Okay. Then the fourth step is redraw the circuit, the simplified one. You have 10. Okay, so now you have this one, you already find the R equivalent. So you have 3 ohm. You have 6 ohm. You have 3 ohm. This is 10. Okay, so you can see that 3 ohm, 6 ohm and 3 ohm is parallel. So this is R equivalent 4. So R equivalent 4 is equals to 1 over 3 plus 1 over 6 plus 1 over 3. So this one is equals to
1.2.
4.2?
1.2.
1.2. Okay, 1.2 ohm. Okay, and the last one, you have 10 ohm. This one you already find the R equivalent. So this is the R equivalent. Like this. So this is 10. This is 4. This is R equivalent 4. Now you want to find the R equivalent. So R equivalent 10 ohm and 4 ohm is in series. So it is basically 4 plus 10. So this is equals to 14 ohm. Okay. Sorry. This is 1.2. Okay. 1.2. So this is 1.2. Okay. So 1.2 plus 10. The final answer is 11.2 ohm. Okay. So any question? For example 2.10. Okay, I hope you managed to jot this down. Okay, so next is practice problem 2.10, page 49. Okay, let's do practice problem 2.10. Page 49. So this one. Okay. So you have this circuit. The question asks you to find RAB. So RAB is over here, is basically the R equivalent. Okay, so basically this circuit is the same as this circuit. It's just that I redraw it to be like this. Okay, it doesn't matter how you draw. If you want to draw it like this, then it's okay, but I like to draw it like this. Okay, so from this circuit, first determine which resistor that you can simplify. Okay, so over here you know that 20 ohm and 5 ohm is in parallel. Okay, so I name this as R equivalent 1. So R equivalent 1 is 1 over 1 over 20 plus 1 over 15. 5, sorry. Okay, so you will get equals to 4 ohm. Okay, so from this figure, you can simplify it to be, now this 20 ohm and 5 ohm is now a single resistor with a value of 4 here. Okay, so now you have this circuit. So you can see that 4 ohms here and 1 ohm is in series. Okay, so I name this as R equivalent 2. So R equivalent 2 is basically 4 plus 1, which is equals to 5. Okay, next from this circuit, you will get the circuit in 3 here. Okay, so now instead of having 4 and 1, now you have a single resistor with a value of 5 here. Okay, so from this circuit you can see that these two resistors, 20 ohm and 5 ohm, is in parallel. Okay, 20 and 5 ohm is in parallel. So R equal 3 is 1 over 1 over 20 plus 1 over 5, and you will get 4 ohm. Okay, next now instead of having this 5 and 20, now we have 4 ohms over here. Okay, so this is the simplified circuit. So from this circuit you can see that 4 ohms and 2 ohms here is in series. So basically they are equivalent for this one is equals to 4 plus 2, which is equals to 6 ohm. Okay, and finally, not yet finally, but for because R equivalent equals to 6, now you have a circuit like this with the R equivalent 4 is over here is equals to 6. Okay, so from this circuit you can see that this 18 ohm, 1 ohm and 6 ohm is in parallel, so I name it as R equivalent for 5. So R equivalent 5 is basically 1 over 18, 1 over 1 over 18 plus 1 over 9 plus 1 over 6. We have 3 resistor, so it is equals to 3 ohm. Okay, now the final circuit is like this. You have 8 ohm and you have the R equivalent 5 over here, and now you can calculate RAB. So RAB is looking from this side. Okay, so over here you can see that 8 ohm and 3 ohm is connected in series. So 8 plus 3 is equals to 11. Okay, so any question? Please make sure that you jot this down. So in your test, in your final, please make sure that the calculation is step by step in order for you to get full mark. Any questions? Okay, so no question. Okay, so now we will continue with the new subchapter, which is the current and voltage divider. Okay, so this is just a recall from what you have learned previously. So if you have a series circuit like this, so the current that flows through the current I1 over here is the same as the current I2, is the same as current I3. Okay, because it's a series, it is connected in series. Okay, and okay, so consider the following figure over here. Over here you have a series circuit. You have R1 and R2 connected in series. So you can calculate for the R equivalent. So since it's a series circuit, so the R equivalent is equals to R1 plus R2. So you can simplify this circuit to become this circuit where the resistor here is equals to R equivalent. Okay. Next, applying Ohm's law to each of the resistor. Okay, resistor R1 and R2. So remember the Ohm's law. So Ohm's law is V equals to IR. Okay, so Ohm's law is V equals to IR. So applying Ohm's law to each of the resistor, basically you can calculate for the V1. So V1 is the V across R1, V2 is the V across R2. So V1 is equals to I R1 and V2 is equals to I R2. So you look at here, the I is the same because it's a series circuit. Okay, so the value for I is the same. Okay, so you don't need to label it as I1, I2. Okay. Next, by doing KVL, okay, so from this circuit, when you do KVL, Remember KVL last week that you have learned? So this is positive, negative, positive, negative, positive, negative. So you do a KVL, so you will get the KVL equation with equals to V1 plus V2 minus V is equals to 0. Okay, and then you combine the previous equation, which V1 equals to IR1, V2 is equals to IR2. Okay, combine with this equation, then you will get this equation where V is basically V1 plus V2. Okay, so V1 is IR1 plus IR2. Okay, so you can simplify this to become I multiply with R1 plus R2. Okay, so from this equation you can calculate for I, where I is basically V over R1 plus R2. Okay, so from this equation, from this current equation, okay, you can calculate for V1 and also V2. So remember, V1 is the V across R1, V2 is the V across R2. Okay, so V1 is I R1. Okay, so from the previous equation, this equation, V over R1 plus R2, okay, so V1 is I R1. Okay, so from the previous equation, the I is equals to V over R1 plus R2. So multiply with R1. Okay, so basically you have R1 over R1 plus R2 multiply with V, where the V is Vs lah, the V supply. Vs is the V supply. Okay, the source. Okay, same for V2. V2 is I R2. So I is V over R1 plus R2 multiply with R2. So basically it is R2, R1 plus R2 multiply with V, Vs. Okay, so this is basically the derivation for voltage divider. Okay, derivation for voltage divider. The voltage divider is this one. This one is just to show you how to derive these two equation, these two formula. Okay, but usually you just use these two formula. You don't need to derive this voltage divider. Okay, so the thing is you need to remember this one. Okay, so actually it is quite easy to remember this, because for example, if you want to calculate for V1, what you need to do, R1 must be on top. Okay, divide by the resistor that you have. So this one you have R1 and R2, so R1 plus R2, then you just multiply with Vs. Okay, same for voltage 2, V2. So to find V2, you just get the value for R2, divide by R1 plus R2, multiply with Vs. Okay, so this is what we call as voltage divider. Okay, basically if you have this kind of circuit, basically you can solve it using KVL, but voltage divider and current divider is just to simplify your calculation. Instead of using KVL, you just use this formula V1, V1 and V2. Okay. So now, for example, you have this circuit. The question asks you to find V1 and V2 in the circuit. Okay, using voltage dividers. The question stated that using voltage divider, so you need to use voltage divider. If the question doesn't ask you to use voltage divider, then you can use KVL. Okay, it doesn't matter. So this one use voltage divider. So V1, so the V1 is over here. Okay, to calculate for V1, okay, the equation is V1 equals to R1 over R1 plus R2 multiply with Vs. So R1 is 4 ohm. Okay, divide by R1 4 ohm plus 2 ohm. Okay, multiply with Vs. Multiply with Vs. So over here you have two source. Okay, so if you have two source, you must, for this circuit, you need to add 10 volt with 8 volt. Okay. Okay, you need to add 10 volt, 10 and 8 volt. So you will get V1 is equals to 12 volt. Okay, this one actually depends on the polarity of the voltage source. If, for example, this 8 volt over here, the voltage source is like this, so meaning the arrow current is like this. So if you have something like this, instead of having 10 plus 8, your voltage divider is basically V1 is equals to 4, 4 plus 2, 10 minus 8. Okay, so please take note of this. Okay, this is actually depends on the polarity of the voltage source. Okay, so this one is, if you have something like this, then this will become 10 minus 8. But since the polarity is like this, then it's 10 plus 8. Okay, so now let's calculate for V2. So V2 is R2, R1 plus R2 multiply with Vs. So R2 is 2 ohm, R1 is 4 plus R2, which is 2 ohm, and the Vs here is the same as this one, 10 plus 8, so equals to 18. So 2 multiply 18 divided by 4 plus 2, you will get 6 volt. Okay, another thing you need to take note is that if you look at here, this is positive, this is negative, so the direction of V2 is counterclockwise. Okay, but the thing is, supposedly for this resistor, supposedly the polarity should be like this, positive, negative. It should follow the current flow. Okay, so because the V2 is opposite of the current flow, so you must make sure to add a negative value in front of here. Final value for V2 is actually negative 6 volt. Any question? Can you understand why V2 become negative? Hello? Tak ada respon eh?
Yes, doctor.
Yeah, okay. Okay, so next is yes, can. Okay. So next is another example, voltage divider example. So you have this circuit. Calculate the V out. V out, not V out. This is actually V naught. V naught is the V across 4 ohm. So to calculate for the V naught, you can just use the voltage divider. Okay, so very simple. So V naught is 4 ohms divided by 4 plus 6 and then multiply with the Vs. So suppose your answer should be 6.4. Okay, your final answer should be 6.4. Okay, so basically this one, the voltage divider is the simplification from the KVL. So, but if you want to use KVL, then it's okay. It depends on you. So for KVL, it's like this. Okay, then you do KVL, then you get the KVL equation. Find the current, then you can find the V naught. Okay. So voltage divider is the shortcut way to find voltage across the resistor. Okay. So next is another example. You have this circuit. Okay, so this circuit is the similar circuit that you have in your tutorial 2 question number 11, if I'm not mistaken. Okay, so many of you, not many, some of you did ask me whether this is a series circuit or parallel circuit. Okay, so the answer is this. If you have this kind of circuit, this is a series circuit. Okay, this is a series circuit. It's just that the question asks you to find the V not here, but this is the series circuit. So the current flows like this. Okay, no current flows here because it is a series circuit. It's just that the question asks you to calculate V naught here. Okay. So now using the voltage divider, okay, so you can use 6 over 6 plus 2. Okay, 9 minus 3 and you will get 4.5 volt. Okay, but still you can, I want to try using KVL. So KVL is determine the current direction. Okay, so the KVL here is equals to negative 9 plus V 6 ohm plus V 2 ohm plus 3 is equals to 0. Okay, so negative 9 plus 6i plus 2i plus 3 is equals to 0. So I is equals to 0.75. Okay, so you can calculate for V6 ohm, V6 is equals to 6i. Okay, so 6 multiplied with 0.75, you will get the same answer, 4.5 volt. Okay, so now you can actually see that if you use KVL, you will get the same answer as if you use voltage divider. Both answer give you 4.5 volt. Okay, so it depends on you whether to use KVL or you want to use voltage divider. Okay, this question actually asks you to find voltage across 6 ohm over here. Okay, plus minus V 6 ohm. Okay, so next is another example. This one, find voltage across 5 ohm. So this is 5 ohm. Over here, you want to find the voltage across 5 ohm. So this is plus minus V 5 ohm. Okay, so V 5 ohm is basically the resistor 5 ohm divide by 3 plus 5 multiply with Vs. So you have 3 voltage source. Okay, 30, 10 and 8. So you need to determine the polarity of the voltage source. Okay, so if you look at here, 30 volt and 10 volt is counterclockwise, so it's positive. 8 volt is clockwise, okay, so it is negative. So 30 plus 10 minus 8, so you will get 20 volt. Okay, so if you want to use KVL, your KVL equation will become negative 30 plus 3i minus 10 plus 5i plus 8 is equals to 0. So 8i is equals to 32, then I is equals to 4. Then you can find V5 ohm. So V5 ohm is 5i. So 5 multiplied with 4, so you will get 20 volt. Okay, so it is the same. This is using KVL, this is using voltage divider. Any question? Okay, so if no question, then we can proceed to current divider. Okay, so this is just a recap. If you have a parallel circuit, basically the voltage across here, this V1 is equals to voltage V2 is equals to voltage V3. Okay, only if you have a parallel circuit like this. So consider you have a circuit like this. So this is a parallel circuit. So if you have a parallel circuit and you want to find the R equivalent, you need to use this formula. Okay, 1 over R equivalent equals to 1 over R1 plus 1 over R2. Or basically R equivalent is equals to 1 over R1 plus 1 over R2. Or you can use this formula. R equivalent is equals to R1 R2 divided by R1 plus R2. Okay, so from this circuit you can simplify it to be this circuit where the R here is now the R equivalent. Okay, so by applying Ohm's law at each of the resistor, so you know that the V across the resistor R1 is I1 R1 and the V across the resistor 2 is I2 R2. Okay, so over here you have I1 and I2 because it is connected in parallel. Okay, so the current is different. That's why you have I1 and also I2. Okay, so the I1 is basically V over R1 and I2 is V over R2. So if you apply KCL at node A, KCL at node A here, so I is actually I is equals to I1 plus I2. Okay, so you have equation 5 where I equals to I1 plus I2, and by substituting equation 4 into equation 5, okay, so you will have I equals to I1 where I1 is equals to V over R1 plus I2 where I2 is V over R2. Okay, so you can simplify this equation and you will get I is equals to V multiply with R1 plus R2 divided by R1 R2. Okay. So from equation 6, basically you have V equals to I multiply with R1, R2 divided by R1 plus R2. So this is equation 7. So if you substitute equation 7 into 4, you will have I1 equals to I R2 over R1 plus R2. I2 is I R1 over R1 plus R2. So this is what we call as the current division. Okay. This one is the derivation to get this current division, but usually you don't need to derive it, just remember this current divider formula. Okay, so it's quite easy for you to remember. This one, the voltage divider, remember voltage divider V1, you have make sure that R1 is on top because you want to calculate V1. So R1 plus R2 multiply with Vs. However, if you look at here, the current divider, if you want to find current I, the other resistor should be on top, which is the R2. So R1 plus R2 multiply with I. Okay, so the difference is the resistor on top here. Okay, and also this one is for voltage divider, this is the current divider. Okay, so next we have example. So this is a very simple example. You have a circuit like this. The question asks you to calculate for I1 and I2. Okay. So if you have a circuit like this and you want to calculate for I1 and I2, just use current divider. Okay, use current divider. So I1 is equals to R2. Take note. This is I1 because you want to calculate for I1. So the resistor on top this should be R2. Okay, so R1 plus R2 multiply with I. Okay, so I1 is over here. So this is R1, this is R2. So R2 is 3, divide by 3 plus 2, multiply with I. So the I is over here. This is I. Okay, I is 4 ampere. Okay, so 3 divided by 3 plus 2, multiply with 4, you will get 2.4. 2.4 ampere. Okay, for I2 is R1 over R1 plus R2 multiply with I. So that's why R1 is 2 divide, so you will get 1.6 ampere. Okay, so any question? So this is using current divider. So if you want to use KCL, Kirchhoff current law, still you can use it. Okay, but to me I think current divider and voltage divider is much simpler. Not simpler, but faster to calculate using current divider and voltage divider. Okay, so next let's look at example 2.12 at page 50. So you have this circuit. So this circuit, okay, so you're given this circuit. The question asks you to calculate I0, V0 and power dissipated at R3 ohm. Okay, I0 is over here, V0 is the V across 3 ohm. Okay, I forgot to label it here. V naught is actually V across 3 ohm, and also the power dissipated in resistor 3 ohm. So the first thing that you need to do is you need to simplify this circuit. So you can see that 6 ohm and 3 ohm is parallel. Okay, so since it's parallel, you can calculate for the R equivalent 1. So the R equivalent 1 is basically 1 over 1 over 6 plus 1 over 3, and the answer is 2 ohm. Okay, the answer is 2 ohm. Then from this circuit, you can simplify it to Bailey circuit. Now you have 4 ohms and also 2 ohm. 2 ohm is the R equivalent 1. Then you can calculate for the R total. Okay, R total is, because this is in series, so basically the R total is 4 plus 2. So R total is equals to 6 ohm. Okay. So why do we need to calculate for the R total? Because we want to calculate for the current. Okay, current I. Because over here we want to use the current divider. Remember current divider? Current divider is I1 equals to R2 over R1 plus R2 multiplied with I. So I is the current I here. But over here the supply is the voltage supply. So you cannot directly use this value. You need to find I. The previous example, the source here is the current source. That's why you can directly use the value from the current source. But if the source here is the voltage source and you want to use current divider, you first need to find the I. Okay, I total. I is basically the I total. So because you have calculate for the R total, now you can calculate for the I total, where I total is V over R total. So the V is 12 volt and then the R total is 6 ohm. So it is equals to 2 ampere. Okay. After you calculate the I, then only you can use the current divider. So this is the current divider. So you want to find the current here, I naught. Okay. So basically I naught is the current across 3 ohm. So I naught is equals to 6 divided by 6 plus 3 multiply with the I. So the I is 2. And you will get I naught is equals to 1.333 ampere. Okay. So after you get the I naught, of course you can get the V naught. So V naught is equals to I naught R. So I naught is 1.333 multiply with R. R is 3. So you will get 4 volt. And the last one, calculate for the power dissipated at the resistor 3 ohm. Okay, so for the power, there are 3 equations that you can use. So the first one is P equals to I squared R. The second one is P equals to V squared over R. And the last one is P equals to VI. So you can use any of this. Okay, so this one I use P equals to VI. So V is 4 volt. The I is 1.333. So is equals to 5.332. Correct? Okay. So any question for example 2.12? Dah salin ni? Please jot this down. Okay, so next is example 2.13. Okay, this one. So example 2.13, page 51 in the Sadiko book. Okay, so you were given this circuit. Find V naught, power supplied by the current source, the power absorbed by each of the resistor. Okay, each of the resistor. So you need to find the power for 9K, 6K, and also 12K. Okay. So over here, this one you can directly use the current divider because the voltage, because the source here is already a current source. So the current I is 30 milliamp. Okay. So by using current divider, you can calculate I naught. So the I naught is the current that flows through 9 kilo ohm. Okay, because you want to calculate for the V naught. So using current divider, I naught is equals to 18K divided by 9K plus 18K multiply with the current 30 milliamp. So you will get 20 milliamp. Okay, and using Ohm's law, you can calculate for V naught. So V naught is the V here, V across 9K. So V naught is 9K multiplied with I naught. So 9K multiplied with 20 milli, you will get 180. 180 volt. Okay, so V naught is 180 volt. Next, you want to calculate power supplied by current source. So power supplied by current source is PS. Okay, PS or the P total. So PS is, I use this formula, I squared R. Okay, so because it's the power at the source, I need to find the R total. Okay, so remember, if anything involving the source here, you need to calculate for the R total. So the R total is equals to this one. Oh, I forgot to tell you, this one I already simplify. 6K and 12K, that's why you get 18K over here. Okay, so to find R total, okay, you know that 9K and 18K is parallel. So 1 over 1 over 9K plus 1 over 18K, you will get 6K. 6 kilo ohm. Okay, so using this formula, PS is equals to I squared, which is 30 milli, multiply with 6 kilo ohm, you will get 5.4 watt. Okay, and lastly, the question asks you to calculate for the power absorbed by each resistor. So you have 3 resistors. So the first one I want to calculate for P at 9 kilo ohm. So using the formula I squared R. So P at 9K is equals to I naught. Okay, because the current that flows here is I naught. So I naught squared multiply with 9K. So I naught is 20 milli multiply with 9K. So you get 3.6 watt. For P at 6K, okay. So P over here, the current that flows through 6K is Ix. So I label this as Ix. Okay. So it is basically Ix squared multiplied with 6K. Then you need to calculate for Ix. Okay, basically using KCL, you know that I equals to I naught plus Ix. Okay, so basically Ix is equals to I minus I naught, because that's why you have I minus I naught over here. Okay, and squared multiply with 6K. So I is 30 minus 20 milli squared multiply with 6K, you will get 0.6 watt. And the last one, this is P at 12 kilo ohm. So P at 12 kilo ohm, the current is Ix. Okay, so current Ix is equals to 10 milli squared multiply with 12K, you will get 1.2 watt. Okay, so basically you can recheck whether the power is correct. Okay, basically the PS, the power as supplied, should be the same as the total power after you have added the power at 9K, 6K and 12K. So if you recheck this, so this one is 3.6 plus 0.6 plus 1.2, you will get 5.4. So 5.4 is the same as the power at the supply. Okay. So basically your answer is, so 2.13. We have another two example for today. Okay, so if no question, then we'll proceed with practice problem 2.13. Okay, this one. Okay, in the meantime, do you have any question? Okay, no question. Have you done your tutorial too? Okay. For tutorial question 11, dimension find V naught from 6 ohm means that we have two possible answer. Wait, later we will discuss about this tutorial after this. Okay. Okay, so after this we will discuss a little bit about your tutorial. I need to finish this one first. So example 2.13, page 51. No, sorry. Practice problem 2.13, page 52. Okay, so you have this circuit. Calculate V1, V2, P across 3K, P across 20K, and also P across supply. Okay, so if you have a circuit like this, if you remember the previous circuit, usually the source is at the left hand side. Okay, my left hand side. Okay, so if you have a circuit like this where the source is in the middle, you should rearrange the circuit. So if you rearrange the circuit, okay, you will have a circuit like this. Okay, if you look at here, this one and this one is basically the same circuit, is that I rearrange it. Okay, so now the current source is over here. Then 1K and 3K is over here. Okay. So now, after you have rearranged, you need to simplify the circuit. Okay. So 1K and 3K is series. So the R equivalent one over here is 1K plus 3K. So it is equals to 4 kilo ohm. Okay. Then this is the simplified circuit. Okay. So over here, because you want to calculate for I1, so even though this is in parallel, example ada share kat Yulen. Yes, later I will share this example in the Yulen. I will share the example in the Yulen, the PDF for this one. Okay. So this one 5K and 20K is in parallel. So R equivalent 2 is equals to 1 over 5K plus 1 over 20K. So you will get 4 kilo ohm. Okay. So the circuit you will get like this, 4K and 4K in parallel. Okay. Then only you can use current divider. So current divider, you want to find the current over here, I1. So I1 is 4K divided by, this is actually 4K plus 4K. Yes, this is actually 4K, not 8K. So 4K divided by 4K plus 4K, multiply with 10 milli, you will get 5 milliamp. Then you can calculate for V1. So V1 is I1 R. So the R is V1. V1 is over here. So V1 is V across 3 ohm, 3 kilo ohm. So this one I1 multiply with 3 kilo ohm. So you will get 15 volt. Okay. And then over here. So now this circuit, now you want to calculate for I2. Okay, because you want to find V2. Okay, so V2 is the V across 20K. V2 is over here. So I2 is here. Okay, so now this is the simplified circuit. Then you can further simplify because you know that 5K and 4K is a parallel. So the R equivalent 3 is 2.22 kilo ohm. Okay, the simplified circuit, you will have something like this. So you can use the current divider to find I2, which is the current that flows through 20 kilo ohm. Okay, so I2 is equals to 2.22K divided by 2.22K plus 20K, multiply with 10 milli, you will get 1 milliamp. And the voltage to V across 20K is I2, multiply with 20K, so you will get 20 volt. Okay, so next you want to calculate for P at 3 kilo ohm and P at 20 kilo ohm. So just use the formula for power. This one I use V squared over R. Okay, so since P at 3K, so the V is V1. So V1 squared divided by R, so you will get 0.075. And for P at 20 kilo ohm over here, so the voltage is V2. Okay, so V2 squared over R, so you will get 0.02 watts. And lastly, you want to find the power at supply. So power at supply, I'm using I squared R. Okay, so I is 10 milli. I is here. So I is 10 milli. RT is the R total. So the R total, this is the R total. Okay, you calculate for the R total over here. So the R total is from this circuit, R total is 1 divided by 1 over 4K plus 1 over 4K, so you will get 2 kilo ohm. But if you want to calculate the R total using the circuit, also can. So the 1 over 2.22K plus 1 over 20K. So using both circuit, you will get the same R total, which is 2 kilo ohm. Okay, so using this formula for power, so power as supply is I squared R total. So I squared is 10 milli, R total is 2 kilo ohm. So the 20. Okay, so any question? So we have we have the last practice problem, but this one I want you to do it by yourself. Okay, so this one, the final one, practice problem 2.12 at page 51. I want you to do it by yourself. So the final answer, you already have it here. Okay, 50, we have V1, I1, P1, V2, I2, and also P2. Okay, so please do this practice problem 2.12. So if you have any question, you can ask in the next class on Thursday. Okay, so this week we will have class on Thursday. Okay, so regarding your tutorial, so just now your friend asked for tutorial question 11 didn't mention find V naught from 6 ohm, means that we have two possible answer. Okay. So in your tutorial, question number 11, the question asks you to determine V naught in the circuit. The question doesn't ask you to find V at 6 ohm. Okay. The question asks you to find V naught, not V across 6 ohm. The V across 6 ohm is example for this week lecture. Okay, it's the same circuit, but the question is different. Okay, in the previous example that I show you, it is the same circuit, but the question is different. The question asks you to calculate V across 6 ohm. That one is a different question. This one, the question asks you to calculate V naught. Okay, the same circuit but different question. Get it? Okay. So do you have any problems doing regarding your tutorial too? I hope that all of you already done the tutorial until question 13. Okay, and I think some of you already get the answer until question number 13. Okay, so if you have any question, either you can ask me or you can discuss among yourself. Okay. Any more question? So if no questions, then we will continue with our lecture on Thursday. Okay, so on Thursday we will cover um, Y delta circuit. And please remember your tutorial, not tutorial, your quiz. Your quiz is on Friday. Okay, so if no more questions, then we can finish our class for today. So later I will upload the this one, the example, the PDF example, the calculation that I show you just now. Okay. Okay, so thank you.